afternoon from around the world, and thank you for joining us for this interesting topic and webinar on low sulfur fuel oils. I think it's a very hot topic in the world as we stand today. Just to give you a brief introduction, so we're joined today by Per and Kristen from SINTEF, as well as OSRL team, driven by the offshore SME subject matter experts team of OSRL. We'll put this together, and hopefully it can be a start of a great collaboration going forward with regards to low sulfur fuels. So first off, I'd also like to say we have a Q&A chat function. So if anyone has any questions, please, if you could enter that into our chat function, and we will address them after our presentations. So the first presentation is from Per from SINTEF. So Per is a senior research scientist at SINTEF, based in Norway. He has 35 years of experience within the field of oil pollution and has been project manager and scientist responsible for many research programs, including weathering and behaviour of oil spills under various environmental conditions, including Arctic and ice-covered waters, testing of oil spill dispersants and other countermeasures, oil analysis and oil spill identification, and oil spill contingency planning in NEBA analysis. He has comprehensive field experience, both experimental oil releases in open and ice-covered waters, and participated in response operations during real oil spills, including Macondo, the incident in 2010. So welcome, Per and Kristen, and over to you. Thank you very much.
Yeah, thank you, Ian. I hope everybody can hear me. And thank you for being invited to this webinar. And what we want to do is to say a bit about the findings from recent projects we have been carried out here at SINTEF on the weathering behavior of this new generation of low sulfur marine fuels, and also with respect to oil spill response options. So this presentation has been prepared together with my colleague Kristin Rist Sørheim. So just showing the picture here of some of the samples we have been investigated, and you can see even from the visual appearance that there is a wide span of these fuels. So all these studies has been a part of project mostly funded by the Norwegian Coastal Administration, but also we have had support from ITOP and also from the Canadian government through this MPRI program by the Fisheries and Ocean Department in Canada. So then I just will say a bit about the background for these projects we have been running and studies we have been running. And the background is that in order to reduce the atmospheric emission of sulfur oxides in connection to the shipping, there has been a kind of stepwise reduction in the requirements to reduce sulfur content in the bunker fuels. And we have two criteria here. One is the what you call the sulfur emission control areas, where there was in 2015 there was a reduction in the requirements for using bunker in those areas. That is the Channel, it's the North Sea, Baltic Sea, and you also have emission control areas also on the west and east coast of Canada and USA. And from in 2015, there was new regulations saying that the maximum sulfur content could be from 1% down to 0.1%. And now Therefore, we call those oils as ultra low sulfur fuel oils. Globally, outside these SECA areas, there was a new requirements coming into force this year from 3.5% sulfur down to 0.5% sulfur. And these oils is today called very low sulfur fuel oils. So therefore, this new generation of low sulfur fuel oils, somebody is still call them hybrid fuels. They are replacing now the more traditional intermediate and heavy fuel, bunker fuel oils like the IFO 180, 380, etc. By this either ultra low sulfur fuel oils in the SECA areas and very low sulfur fuel oils globally. I just also want to mention that for Norway, we have this island in the Barents Sea, the Svalbard Spitsbergen Islands, and from 2050 there was a requirement there that it is not allowed at all to carry any kind of heavy fuel oils in the vessels that are operating in the nature reservoirs around Spitsbergen. It's only allowed to carry DMI, diesel or gas oil, on board those vessels. So that means also that there is an increasing use of diesel oil on the vessels, and which can also have a varying properties in and depending on the refinery processes. So just a bit about the classification. And I think most of you are aware of this ISO fuel oil standards, where you have two main groups. One is the marine distillate fuels on the left side here, and where you, for example, have the DMA quality, which is the marine gas oil, and the DMB, which is the marine diesel oils. But while on the other side, you have the more traditional heavy fuel oils, which we call marine residual fuels. And the number here, IFO 180 or 380, that is reflecting the maximum allowed of viscosity measured at 50 degrees. So this new generation of low sulfur fuel oils, they are representing a very wide spectrum. So they are not fit into only one of these specific grades. You have them from even from marine distillates, but even up to quite viscous oils, up to what we have investigated is up to 350 centistoke at 50 degrees. So this is a picture from this recent incident at Mauritius this summer with this vessel, the Japanese vessel that grounded on the coral reefs, which was carrying up to around 4,000 tons of very low sulfur fuel oils. And I think at least 1,000 tons has been released to the ocean. And fortunately, this happened in a sea temperature that was, I think, around 27 degrees Celsius. So it was under quite high sea temperature. So if this has been happened more in Arctic area with a sea temperature of 0, for example, the behavior and the property of that surface emulsion that was formed here would have been quite different. Because all of you are aware about these different processes that taking place when oil is spilled at sea, and these different processes they depends highly on what type of oil you are dealing with, what are the sea temperature, what are the wind and the sea state conditions, for example. So to make it a bit simple, if you have oil that are spilled at sea and you have some wave action here, there will be a kind of a competition between will the oil disperse as small droplets into the water column, or will it be the opposite taking place, that water droplets are incorporated into the surface oil and you got what we call water in oil emulsions. And this emulsion can be, with time at sea, can be very viscous and very stable and high viscosity material. And this is something we have seen several times from many type of release an incident with heavy bunker fuel oils, both here in Scandinavia, but also, for example, the Erika and the Prestige spills in France and Spain, which ended up in very viscous material on the surface. And the opposite is if this oil that is built is a more marine or a distillate, you will see the opposite process, that most of the oil will disperse into the water column, particularly when you have bad weather conditions. And this was what happens, for example, during the North Cape spill at Rhode Island for some years ago. So as an example of how to say something about the fate of marine fuel oils at sea, we are showing here some example with prediction of the weathering by using a numerical weathering model, where we are simulating a release of 500 cubic meter of marine gas oil under 10 degrees Celsius and 10 meter per second wind, means that there are some breaking waves present. And this figure here is showing the mass balance from time zero, where most of the oil is on the surface, and we can see that some of the oil will evaporate during some time at sea, up to 5 days. But during the breaking wave conditions, the major process here is that the oil will naturally disperse into the water column due to it's a very light and low viscous oil, and this can give some short-term and local effects, for example, on the marine organisms, as was the case, for example, with the North Cape spill I was referring to. If you are simulating exactly the same release under the same conditions with the heavy fuel oils or intermediate fuel oils, that's an oil which has a much higher viscosity. It's more resistant on the surface. The evaporation will be very low, and also the dispersion will be low. So what happens? There will be a weathering and an emulsification taking place on the surface, and this will persist and finally often end up on the shorelines. So as an example from such heavy fuel oil incident, this is two pictures from the Baltic Carrier incident in the Baltic Sea for about in 2001. This picture here, I often call it this a new high-tech Danish skimmers. These guys here. I hope there is no Danish people listening to me today. And also during the capsize of the Rockness incident in Norway, the heavy fuel oil, a 380, IFO 380, ended up mostly on the shoreline, and it became a very extensive shoreline cleanup operation. So the main question here is, how will this new generation of low sulfur fuel oils behave relative to the experience we have with the more traditional heavy fuel oils? So this figure here shows what we call the temperature sweep of the viscosity. Here you have 50 degrees, and for example, an IFO 380 has a viscosity of around 380 centipoise at 50 degrees Celsius. And you can see here the rest of this new very low and ultra low sulfur fuel oils, they are representing a quite wide span in the viscosity, also at 50 degrees. But for us oil spill persons, we are more interested what happens if these oils are cooled down to the ambient sea temperature when you have a spill of these oils. And you can see there is a significant increase depending on in the viscosity, depending on the decreasing sea temperature here. And you also see that for some of this oil, there is a particular high increase in the viscosity with decreasing temperature, except for the marine diesel oil here. And the reason for this very high steep of increase in viscosity has something to do that also for some of this oil, they have a very high pour point. Two of these oils we were investigating had a pour point around 24 degrees, and which is quite high compared to particularly marine diesel, but also many of the older heavy fuel oils have a much lower pour point value. So this is just an example of one of these oils that had a very high pour point of 24 degrees. So that means when Oddveig in our laboratory come next morning and the sample has been standing at room temperature, this sample of oil was actually has solidified, and it has what we call elastic properties. You can just turn the bottle upside down and it was solidified. And this is quite opposite to the more traditional heavy fuel oils, which are very viscous, but still they have viscous properties and are still floating as a liquid. Another things we were looking on is to say that we could say something about the emulsification properties. And this is something we do by using what we call rotating cylinders, where we have filled the cylinders with 1 part of oil and 10 parts of seawater, and let the cylinders rotate for up to 24 hours. And what we can see here, when we stop that cylinder after the rotation with the diesel oils, DMI gas oils, the oil is just coming up to the same position. There is no uptake of water in the diesel oils, which is an opposite to all the other more heavier diesel, this wide range diesel, but also the hybrid oils that could form emulsion up to 75 to 80% water with such kind of rotation and energy mixing. And this means, for example, if you have an oil that is taking up 75% water, there is an increase in the volume of the material, which is increasing with a factor of 4 compared to the amount of oil that was released. And the other very interesting observation with this oil with a high pour point is when we did some studies in this oil weathering flume basin we have at SINTEF, and we had the temperature on the seawater, which was very cold, let's say 2 degrees Celsius. And with a pour point of 24 degrees with that oil, when we put that on the surface, it's more or less immediately solidified into kind of black lumps here on the surface. But with time, during some hours or even days in this flume, where you have some breaking waves, you have some evaporation, this oil become more and more light brown in color. And the reason for that is that you got a kind of a layer of emulsion around the solidified water-free oil that are inside as lumps into that emulsion. And the funny thing here is then when we finished those experiments after 3-4 days, and we finished it by applying dispersants into the flume, we were able to partly disperse the emulsion phase, but the water-free oil lumps, they were not dispersible at all. So there was a kind of two phases generated. It was the oil lumps that were inside, and you have this emulsion that was formed outside. And this is a picture from the same oil during some testing which the Norwegian Coastal Administration did in their test basin in Horten, with different kind of skimmers they were testing with this oil. And I hope you can see the movie here. You can see that due to the high pour point, that the flowability is very low, so the access of the skimmers to the oil become very low. The oil is not floating into the skimmers, so the recovery efficiency was extremely low with that particular oil. So it's not time for me to go into detail with all the data that has been generated in the laboratory, but just say that all the data of the different oils, both in fresh and the different degree of weathered samples, which we analyzed, they are fed into a numerical model, and we are then able to predict the properties as a function of time at sea under chosen environmental conditions. We can select the flow rate, the release rate, the wind speed, the sea temperature, the film thickness, etc. And we can say something how rapidly the evaporative loss, the increase in viscosity and density, the emulsification formation, etc. And we could also predict what will be the time window for use of dispersants, and also what will be the effective time window for in-situ burning, when what are the time window for ignitability of the oil, for example. So the outcome of such model prediction is showing as examples here, where we show the pour point for the different new generation of low sulfur fuel oils. We can see there is a wide span in the pour point of these oils under similar predictions, and also the viscosity of these oils is a very high and wide span in the viscosity between these oils, and this you can see the increase here as a function of time at sea. I would also just mention that in these studies we have also checked the relative toxicity of these oils on marine organisms, and this is done by preparing what we call water accommodated fraction during a standardized method, the Crusoe method, and we are testing the toxicity of the relative toxicity of the water with two different marine species. And in general, the solubility and the toxicity of this residual low sulfur fuel oils has a fairly low toxicity to the marine organisms compared to the different type of marine diesel oils that can have a quite different in both in the solubility but also in the toxicity. So there was a quite wide span, which likely is reflecting that there are different kind of refinery processes for preparing this distillate fuels. Yeah, so I see I'm using my time here, and from an oil spill response point of view, I think it's very crucial to have a good knowledge of the variability in the weathering processes, both of the fate and the behavior of the oil, and also the response capabilities of these new oils which now are coming on the market. And I think that this project we have done so far has been a start in mapping these properties. What we have seen so far is that there is a wide span in the physical-chemical properties of these residual low sulfur fuel oils, which likely is reflecting the different refineries' recipe in the process to comply with the new sulfur limits. We also see that many of these residual low sulfur fuel oils has a high degree of persistence on the sea surface with high viscosity, and some of them has also high solidifying properties, while the solubility and the toxicity of these oils to the marine organisms in the water column is fairly low. But anyway, the oil spill response of these residual fuel oils can even be actually more challenging than this previous traditional heavy fuel oils, particularly in cold water spill conditions. That's what we can see from many of these oils. We can see there is a fairly low potential for the use of oil spill dispersants. There can be a low potential also in the ignitability for in situ burning. And we also believe that the type of skimmers will be the selection of type of skimmers will be very important for the efficiency of a mechanical recovery operation. So, as I said, there is today now an increasing number of such low sulfur fuel oils that are now coming on the market as more and more refineries are starting to produce this oil according to the new sulfur regulations. So I think there is a need also for the future testing of this in a more systematic way. We don't have the total overview yet. And it's good to know that there are, at least what I know about, is at least 2 R&D projects now that has been initiated this year. One is called the EMAROS project, which is funded by EU and is organized and led by the Norwegian Coastal Administration. And there is also a project within the EPPR and PAME in Arctic Council, dealing to look more specific on the behavior and the difference between the different oils under more Arctic conditions. Yeah, so I think just also mention that we at SINTEF at the moment, we are going to evaluate, and also for next year, we are planning to test different type of skimmer concept with oils with heavy, which are very waxy and have a high pure point. So this is just showing some of the skimmers we are evaluating at the moment, because also in Norway, in addition to this low sulfur fuel oils, we are also starting to produce some crude oil production in Norway with extremely high wax content and high pure points, which you can see there is a bit the same challenges as you may have also with this, some of these high fuel oils with very high pure point. So that's more or less what I was thinking to say. I was thank you for the attention, and I would just also want to mention that all these reports, they are open reports. You find them on the Norwegian Coastal Administration homepage, and I also think that they are also on the website for at ITOP Fair. So thank you very much.
Thank you very much, Per. Thank you for sharing your information and your knowledge. I think I'm getting some feedback. There we go. Yeah, thank you very much, Per. The information and knowledge, especially in the new times, are valuable. So thank you very much. So just going on to low sulfur fuel oils and where do we as OSRL stand and what next for OSRL really. And if we could go to the next slide, please. Thanks. So Now, what does this mean for OSRL? Understanding all of this information and dissecting all of this information, that the peers shared with us. So we understand the industry is an ever-evolving world, as you can see, and we always prepare for the best as possible, for any variation that any response may throw at us. And based on the information received so far, be it a little bit of the greater world, we have a much better understanding of the variability in properties and characteristics of some of the low sulfur fuels that we've seen today. It's also highlighted some of the challenges and the areas where we can improve preparedness. I mean, Per has mentioned some of the, how do we get this low sulfur fuel oil, to a skimmer, for example, based on the thickness, like that video that you've shown us, Per. But reassurance as well that we still have the combination of a wide range of equipment and strong expertise and experience to respond efficiently and effectively to any given spill. Next slide, please. So what next for OSRO? What does this mean? Well, we recognize that more work is required, and that there's some gaps in the knowledge and understanding of a low sulfur fuel oil. And it exists, it applies to OSRL and the wider industry as well. And we need to drive to continue to close the potential gaps and increase the knowledge and response variations and engaging with partners. But further to get a greater collaboration with partners, industry, and to carry out joint initiatives, practical exercises, get practicing, get hands-on with equipment and low sulfur fuel products, and allowing us all to continue to strengthen our knowledge and in an effective response strategy. Next slide, please. So to sum up, in closing, briefly from OSRL side, is the new low sulfur fuel oil formulations bring with them new challenges in oil spill preparedness and response. And by drawing on our expertise of other heavy oil products with high emulsification rates, such as oil emulsion, for instance, OSRL are confident in our ability to rise to this new challenge that is presented to the world. And we'd like to ask our clients and the wider industry to share low sulfur fuel information with OSRL and allow us as a team to better understand the variabilities of low sulfur fuel or ultra low sulfur fuel, and together ensuring effective and efficient emergency spill response. And as you can see, that last little comment, the better we know the product, the more effective we can be together and for you as an industry. So thanks very much. I appreciate that there's a lot still to learn and understand with low sulfur fuel oils, and let's get stuck in together and get exercising, get practicing, get our hands on product so that we can test it and be the most efficient we can be. There may be some questions.
Yes, hi, we do have a few questions. Okay. First we have you done detailed chemical analysis to see how the PAHs vary among these oils? And I think that's a question for Per.
Yeah, as a part of this toxicity testing, we are doing a detailed characterization of the target components, which including most of the PAHs, both in the oil, but also in the water soluble, the water accommodated fraction as well. So we have all those data.
We have one more with reference to the type of skimmer that have any trials been conducted using steam injection? Might be one for you, Ian.
So in answer to that, steam injection is definitely one of the strategies that have been thought about. and equipment been sourced to carry out that type of recovery. But from OSRL's point of view, that is the very next step, is to take that into the practical world and test that thought. But that's a very good option for sure.
Next question is, have SINTEF results been shared with OSR equipment manufacturers so that they can develop better response options and tools? I think you might be muted there, Per, but that's one for you.
Could you repeat that question?
Sure. Have SINTEF results been shared with OSR oil spill response equipment manufacturers so they can develop better response options or tools?
Not so far. It hasn't, but that's like a good idea that that this information and also the coming information in the new coming projects also will be hopefully can be shared. I know that, for example, in this EMAROS project, the EU project, there is a quite extensive part of that program where the Norwegian Coastal Administration are planned to test different kind of skimmers. It has not been decided yet what type of skimmers, so there could be a good idea here also to contact those people who are planning that for next year. But that's I think there are 6 countries of EU which are running this EU project.
Great, thank you. Someone's asked if there will be a recording available afterwards, and everyone who's registered for this event will receive a link to the recording, which will probably be made available either later today or next week. You can check on our website in the technical library. Next question is, have you tested the toxicity of these oils to sensitive life stages of marine organisms, for example, embryonic fish?
Yeah, actually, we have done some specific studies also on fish larvae and fish eggs as well. In addition to this more traditional standard species, I was showing in my presentation. But so far, I think there's a lot more to do here, and also to look more into the detail of these oils, and also to find if there are any. Is it the same type of oil or components that are dissolved, or are there any other components in these oils? But I don't think we necessarily there are. I don't see, but I'm not familiar what are the refinery processes in producing such oil. I think much of it is actually that the feed, the type of crude oil that are primarily using crude oil in the refinery process that has a lower sulfur content itself. In addition that there are some desulfuring sulfur cleaning of the oil also in those processes, but that's actually not my expertise area.
Thank you. And then we have Jonas Paulsen from the Swedish Agency for Marine and Water Management is asking, I may have missed it, but has there been any corresponding toxicity and response equipment in warm waters and/or freshwater, as for example the Baltic Sea? Any speculation what the difference would be in freshwater?
Yeah. Well, we haven't. What we know is in general, when you have a salinity of around 10 ppt, as you may have in the Baltic Sea, compared to 36 ppt in the marine life, there may be some higher solubility of those components, but there may also be some other kind of organisms to be used of species for test organisms, because they are more freshwater or brackish water organisms. So we have not done that so far, no.
Okay. This is one for someone from the OSRL team. Are OSRL working with OSRL, oil response equipment manufacturers to develop suitable equipment for this?
So yes, to answer that one, we're in that stage at the moment. So we're now engaging with as many as we can with the different types of equipment, like water injection. How can that be added to current equipment that we have, and modifications to new equipment? So yes, that engagement is happening as we speak.
Great. This is a question about dispersants. Could any kind of dispersants be used in these types of fuels?
Yeah, we have done some screening of different kind of dispersants here, and we don't see any big difference here. The good traditional, most modern dispersants we have had the last 10-20 years, they are still also working fairly well on this hybrid oils. There can be some variation between some of the dispersants here, but in general, we don't see any dramatic change in the dispersibility. But of course, the limitation you may have due to the physical properties of with high pour point, for example, is a physical limitation for using any kind of dispersant, because the dispersants are not, when you apply dispersants on solidified oil, the dispersant droplets are not able to penetrate into and be mixed into the water, into the oil phase here. So that's a physical limitation in that way.
Okay, and this is another one for you, Per. I know you did mention working with Canada and other countries, but have you tapped into other countries, what other countries have been looking at, for example, NOAA and others?
No, not particularly with the low sulfur fuel oils. No, but we have over the years we have had quite good contact with NOAA, with Steve Levin, for example, and those people. So we have had quite good contact, but not recently, particularly on this issue here.
Another one, this one's for you, Per. Can you predict the physiochemical properties based on basic data, such as density and pour point, includes in SDS or other sources?
Yeah, this examples I showed with the SINTEF oil weathering model is can operate on different levels. What we see the strength of this model is that we are able to feed into the model both detailed information of the fresh oil, but also information about the weathered samples based on quite extensive laboratory testing, and that means you got a very high degree of predictions, which has been calibrated also through field trials in, for example, in the North Sea. But we are also able to do predictions only based on crude assay data, for example, and spread a very limited data also. But of course, the prediction quality may not necessarily be the high as you may have when you have a detailed information about the weathering properties of the specific oils, as when you have that. But you can actually operate the model on both levels here.
Okay. Lee Barber is saying, it's interesting to see the emulsification trails. It reminds me of the sea lion in Falkland Islands, crude oil. Have you conducted any fur and feather tests to assess how sticky the oil is once it's emulsified?
Yeah, so what we do is to test the properties like the viscosity, the stability of those emulsion, a bit of stickiness? Can you use emulsion breakers and that kind of test we are performing when we are preparing this emulsion with this rotating flask? This is a very old standard method that has been been used by laboratories since Don Mackay in Canada invented it for 40 years ago. So it's a very simple method, but it can be very useful in screening the emulsion properties of the different oils here.
Okay. There's one actually, I think, for you, Ian. Industry collaboration needs to address LSFO challenges. Do OSRL have any ideas as to how this would look? So a collaboration, what that would look like?
The initial collaborations that have been thought of at this stage is to have joint initiatives where we can get our clients or members or industry who have the product, and we can use the equipment, the technologies, the expertise in recovering with them. So we supply the equipment and product and expertise, and they supply the product, and together we can work to better understand the best methods of recovering and storing the product. So at this stage, that is the collaboration that is thought of. If anyone has any other ideas or suggestions, we're happy and open to think of them and pursue them.
Okay. Fergus is asking, how is the response industry keeping track of the new UV LSFO production to then assess what the appropriate response may be, recognizing the different properties of these oils already tested?
From OSRL side, we haven't looked at that as yet, to the best of my knowledge. Per, from your side?
No, well, we have very close contact here in Norway with, for example, the Norwegian Coastal Administration, which is the operative governmental response organization in Norway for dealing with oil spills along the Norwegian coast. So we have good contact with those people. They has been the main financing this project as well. So they are really aware of the issue here.
Okay. This is the LSFO spilled at Wakashio spill in Mauritius have very different properties to those in the oil SINTEF have tested. So are the results from these products applicable across a full spectrum of UL SFOs?
Yeah, that's an interesting question, because in cooperation with Cedre in France, we will get a sample of this oil that was recovered from the tanks on that vessel, and in this cooperation with Cedre, we will investigate this particular oil more in detail to see how different this oil is compared to those very low sulfur fuel oils we already have investigated. So that's something which will include both bench scale testing, which I showed you here, but also some mesoscale flume testing at a different temperature. So that's both under more temperature, but also under very cold sea temperature. So that is something which will take place the coming months, actually.
Okay. In comparison to cold water, have you tested for temperature seawater as found in Red Sea or Arabian Gulfs?
No, because as I mentioned, we have primary focus on temperature that are relevant for the Norwegian water and also the cold water. That means more North Sea temperature and also more Arctic temperature. Primarily because that's because the Norwegian Coastal Administration has been financing these projects for us.
I have another one for you, Per. Do we know the current prevalence or occurrence of LSFO or ULSFOs in the shipping industry worldwide?
Could you repeat the question?
Do we know the current prevalence or occurrence? So I think he's asking, Gary's asking how prevalent is that the use of LSFO and LSFOs in the shipping industry worldwide?
Yeah, maybe I'm not
how much it's used.
I mean, today they have to follow the international rules. So are they inside the emission control areas? They have to use ultra low sulfur fuel oils. Or globally, they have now to use the very low sulfur fuel oils. And I know I recently got some statistics from OSRL actually recently here showing they have a quite good updated statistic of what are the variation of the, for example, the viscosity of the different oils that are bunkering on the different vessels in different ports here. So there is some data, but that's very limited type of parameters they are measuring on. It's primary the viscosity at 50 degrees, and here we see that there is a wide range and a wide span in the viscosity of those oils. But I assume that all the vessels that are on the sea now, they have to follow the criteria with either ultra low sulfur fuel oils or very low sulfur fuel oils, unless they have some scrubber technology on board the vessels.
Mm-hmm. Tessa's asking, actually, have herders been investigated, or are they going to be looked at into as an option? Herders. Yeah,
we haven't. Herder has not been tested on these oils. No, they haven't. But and we know in general that there are limitations with the effectiveness of herders, both with respect to the physical, the viscosity of the oil, and also particularly if you have a very high pour point and low sea temperature. We know the effect of the herders are very limited. In addition, that herder is also working mostly when you have very calm sea conditions.
Okay, thanks, Per. I think this is one for you, Ian. Has OSRL any recent experiences of spills with low sulfur fuel oils? And did the oil behave the same as in the laboratory tests?
So in answer to that, no, we haven't been to any spills with low sulfur fuel as yet, but expecting them to happen, we've expected them to happen from yesterday already type thing. So, but not as yet, no.
All right. Okay. I think that's it. That's up for questions. But
thanks very much. Yeah.
Per, thank you so much for joining us today. This was a really interesting topic and lots of really great questions. And hopefully we can have more discussions about this in the future.
Mm-hmm.
Thank you to everyone for joining us. Per, did you have anything to say in closing?
No, thank you very much for having the opportunity to give this presentation. So thank you very much.
Thanks again, Per, and thanks everyone who joined us. And the link to the recording for this webinar will be available on our website.
Thanks very much. Yeah.
Have a good afternoon, everyone. Cheers. Thank you.
Thank you, everyone.
Thank you.
Bye.